paper clip there.
Okay. So we are, we actually have 2 sections left in chapter 2, and then we're moving into chapter 3, so I'm kind of doing tests a little bit weird. We're not just doing chapter tests. We're going to do tests every few sections in this. So we have spent a lot of time talking about tangent lines. And what is a tangent line in general?
It touches one point.
Touches our graph at one point. And we talk about the slope of that tangent line, right? The y2 minus y1 over x2 minus x1. And to actually approximate the slope or the slope of the tangent line at a particular point, we made those tables because we had to look, you know, as x was getting closer to a certain value, what was your slope getting close to? All right, so that's what we have been doing. Let's kind of practice writing the equation as tangent line, but I'm not going to make a table this time because when my x is getting closer and closer to 1, when you did your table, you would do 0.9, 0.99, 0.999. That's really just the limit as x is getting closer to 1. And now we know how to evaluate limits. So we are going to try to actually just keep this in limit notation and see if we can work it out. So if we think about the slope, here's a point, 1, 1. We need 2 points. So the other one, I have my x value and the y value of this is just x squared. So I need to do the limit as x approaches the x value of this point. So the limit as x approaches 1 of the slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Can you just plug in the 1 here? No. So what do we do?
The cancellation.
What do we have to do before we cancel?
Do a factor.
So this is x plus 1, x minus 1 over x minus 1. So now those drop, which means now we can plug in, so we get 1 plus 1 equals 2. So this is the slope of my tangent line. I asked for the equation, so now we take our point and our slope and plug into y equals mx plus b. So my y is 1 equals m times the x, which was 1, plus b. So my y-intercept is -1, and the equation is y equals 2x minus 1. So we got the actual equation of the tangent line at that particular point. All right. We would like to be more general than this because sometimes we are going to need the slope of the tangent line at multiple points. And so if I'm plugging in those x's from the beginning, then I have to redo the problem every time I give you a different x value. So if I ask for the same tangent line at 2, you would have to start from scratch. Okay, and then if I ask from 3, you'd have to start from scratch again. So sometimes we'd like to be more generic and kind of get a formula for what the slope of those tangent lines would be. So then we have the formula, and then at the end I could just plug in whatever x's I want. So here is another notation for the same thing. And let's kind of break this down. Think about what we just did. We are saying the limit as x approached a particular value, a. Right? This time it's saying the limit as h approaches 0. But if you look at the picture, a here is just representing a starting point. A plus h is representing another point on the graph. Okay, so if my x is getting closer to this point A, what has to be true about your h value? The h is how far apart they are. And if I want it to get closer to this, my h has to get smaller. So that's why it says h is going to 0. So if my h, the distance between those points, is getting smaller, then my point is really just getting close to a. Does everybody agree with that? All right, so then if we think about f of x minus f of a. All right, that was just the two y values. So if my points are a and whatever I get when I plug a in my equation, the second point is a plus h and whatever I get when I plug a plus h in my equation. So when you do your slope, you do f of a plus h minus f of a. Over a plus h minus a, if I set up the slope. What happens to these a's on the bottom?
You cancel.
They cancel. And so that's where that formula came from. So h is just representing the distance between 2 points. So I'm making that get smaller so the points are turning into one another. And then this is just a result of the slope. y2 minus y1 over x2 minus x1. Okay, I really want to.
Yeah.
Okay, so here's, for whatever reason, your textbook, in this section, they use a plus h and a for your notation. And the next section, they start switching and they're like, hey, instead of a, let's just use an x. And they turned into x plus h minus f of x. So I can follow the notation in the book and use a right now and x in the next section, or if you want, I can go ahead and just switch to x's now because in general we're going to use an x and not have an extra a in there. It's really not a big deal. They both represent x values, so it's just whatever you get used to. Would you guys care if I just went ahead and went to x's now so that we're not just switching notations in the next section and we just kind of get used to one thing? Is that all right? Okay. So just know that, like, if you're checking your answer in the back of the book, they're going to have a's and we're going to have x's, but it doesn't matter. Okay. So I'm going to use this calculation to find the equation of this tangent line, y equals 3 over x, at the point 3, 1. And I'm actually going to do it two ways, using the first and the second method. I'm asking for the second one first, which what we just decided is when I'm talking about the second one, we're doing the limit as h approaches 0. We are going to go ahead and switch it to f of x plus h minus f of x over h. The benefit of this, sometimes it's a little bit easier to calculate because your denominator is just an h. So all I'm trying to do is get an h to cancel out versus like 2 terms, x minus 3 or something like that. So it can be a little bit nicer to work with. So if I go through and calculate this, we have a limit as h approaches 0. What is my x in this scenario? Yep, if I want this point, my x is going to be 3. So this is limit as h approaches 0, f of 3 plus h minus f of 3 over h. Okay, f of 3 plus h means you go to your equation and I replace my x with 3 plus h. So I have 3 over 3 plus h. Function notation. So this is my function, 3 over x. Think of it like this. F of x is 3 over x. If I ask for f of 2, you'd plug a 2 in for your x and be 3 over 2. If I said f of 5, it'd be 3 over 5. So when I say f of 3 plus h, you're just replacing your x with 3 plus h. Minus f of 3. If you plug a 3 in here, what do you get out? 1. 3 divided by 3 is 1. All over h. Okay. Somehow, I need to clean this up. I'm hoping my h's will cancel. Do you guys remember what trick we've used when we had like a fraction and a fraction? By the thing in the denominator. So right now, if I look at this, my denominator here, I've got a 3 plus h in the bottom of that. So let's take everything times 3 plus h. If you do it on top, you have to do it on the bottom because we can't change our problem. That's a trick that we use a lot in trig too. So if I have 3 divided by 3 plus h times 3 plus h, that just turns into a 3, minus 1 times 3 plus h, and that's 3 plus h. And on the bottom, I'm hoping things cancel, so I'm just going to leave it as h times 3 plus h. Alright. Is this helping me? What are we going to do? If you distribute that negative on the top, you get positive 3 and negative 3 cancel, so negative h over h times 3 plus h, so then we can cancel an h. So we get negative 1 over 3 plus h. And you plug in your 0, so we get negative 1/3. What does that number represent? The derivative, I guess I haven't called it a derivative before, have I? Sorry, the limit as we approach a certain number, that is my slope of the tangent line. So if I want the equation of the tangent line, I have to take my point and my slope and plug into y equals mx plus b. So we get y equals negative 1/3 x plus 2. I wanted to work the same problem the other way just to show you two different calculations, but they are the same thing, just different. They look different, but mathematically it's equivalent. So we're going to redo this problem, but we're going to do it the way we did the first one. So using f of x minus f of a over x minus a. Or if we just think of it as 2 points. Okay, here's my first point, 3, 1. My second point would be x, and what's y equal to?
3.
When you do it this way, you do the limit as x gets closer to 3. And then we just set up our slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What would you do on this one? Okay, I take everything times x. We get 3 minus x over x times x minus 3. My goal is that for things to cancel out. Does anything cancel yet? Can I make things cancel?
Yeah.
How?
The 1 over x.
Hmm?
Is it the 1 over x?
We actually don't even have to do that. let's take out a -1. So if I took a -1 out the top, that gives me a -3 plus x. -3 plus x, isn't that the same as x minus 3? So those cancel, and I get -1/3. Is that the same thing we got for the slope on the last one? Yeah. So then you'd be back to writing your equation, which for the sake of time, I'm not going to do that. But we get the same slope. So I just want to show you several of the homework questions are just going to say, find the equation of the tangent line. I don't care which of the two methods you use to find your slope. They both work. All right. Any questions so far? So just like when we talked about tangents at the beginning, we related that to velocity. And like we talked about reviewing for our last test, average velocity is just a single slope calculation. So average velocity is just displacement over time, or if we use this notation, y2 minus y1 over x2 minus x1, and you get that. Instantaneous velocity is when we looked at the tables to figure out what they're going to. So instantaneous is the velocity at one particular point in time. So that's when you throw the limit in front of it. Okay, so if all you're calculating is this is an average velocity, a velocity at one particular point, or between 2 points to give us a single number. When we do the limit, that's looking at what those values approach, and that's the instantaneous velocity. So let's take a look at this problem. I think we did one very similar way back at the beginning when we were making tables for everything. I think we might have done this exact problem with a table. But I want to do it again using what we know now. Are you guys going to make it today? Why is everybody so thin? Alright, so suppose that a ball is dropped from the upper observation deck, 450 meters above ground. What's velocity after 5 seconds? So velocity, if I want velocity at one particular point in time, is that average or instantaneous? Instantaneous. Average you have to have between 2 points. Like starting at time 0 until I get to time 5. So what I need to do here is a limit. We can set it up one of two ways. We could do the limit as x approaches 5, like we kind of did it in the past when we made the table bigger than 5 and smaller than 5. But now we also have that way where we could use the h and do the limit as h approaches 0. So I'm going to do that one. I didn't really specify, so technically you could do either. So limit h approaches 0. And we said we are going to do f of x plus h. So here's my equation.
Wait, I thought we were doing a limit of 5.
Okay, so that's why I'm saying you can do 2 ways. You can either do it as x approaches 5 or as h goes to 0. So here's essentially the difference. With the first one, you have 5 whatever, and then basically an x and a whatever. In this way, we use 5 for the first one and x plus h for the second one, and we make the x or the h get smaller and go to 0. So it's really just a matter of, do you want to use this one or this one? And just like the last problem, we worked it both ways. They are equivalent. You could do either. I'm just using the new one to practice it. So if I set it up as the limit as h approaches 0, we have to do f of x plus h minus f of x all over h. All right, f of x plus h means I go to this equation and I'm replacing my t with an x plus h in this scenario. Except if I'm at 5 seconds, what is my x? 5. So I could go ahead and change this to a 5 plus h. Minus f of x is when we are at 5. All over h. Alright, so you have to kind of do a little math and simplify all this. So could I? We only have 2 terms here. They both have a 4.9. Would you guys care if I just factored that out to the front? So if I pulled out 4.9. 5 plus h squared, so if you write it twice in FOIL, you get 25 plus 10h plus h squared. Minus 5 squared is 25. All right, now what? Positive 25 and negative 25 cancel. So you can either distribute that 4.9 or factor out the h. So then I can cancel an h, so now I can plug in my 0. And we get 49. This was velocity, so it would be meters per second. Is that one okay? I think I'm going to skip B for now. I really want to focus just on this tangent line piece. So it turns out, I've already slipped it up and called it this like 3 times this hour, but this calculation that we're doing is what is called a derivative, which is what we are pretty much going to spend the rest of our semester doing, finding derivatives of things. We will learn better ways to find our derivatives, so we aren't going to have to do it like this limit piece forever, but we do have to have that to get us going. So when we have a limit of this form, this is a derivative. A derivative just means the slope of the tangent line, right? They come up anytime we're talking about rates of change. This derivative component, that's why you have to have calculus if you're a business major, or if you're going into the medical field, or all these different kinds of things. It measures a rate of change. So you can look at it like a profit. If you're looking at like in a business and you have an equation for your profit, the derivative tells you how your profit is changing. You know, it's rising really fast if I'm producing this many items, but when I start to produce this many items, my profit is going to start tapering off, and it kind of helps you maximize your revenues and those kinds of things. So there are lots of applications which we will spend a lot of time on. We'll just kind of bring in some here and there just to kind of show you some of those pieces. So this is the big thing. Put a big star next to this, highlight it. We could do either notation. The 2 calculations that we were doing at the beginning, they're both the derivative. This first one is what we are going to do most often, because when we start dealing with radicals or anything like that, it's a lot easier just to reduce an h off the bottom versus an x minus something. So algebraically, this one's going to be a little more user-friendly. The other notation is f prime of a. So that little tick mark represents a prime or a derivative. So I might just say find f prime of a, and I'm just saying find the derivative of this piece. And that is our definition of a derivative. Like we said, we're going to go ahead and instead of a's, we're just going to use x's, because in the next section they go ahead and say, let's start using x instead of a. So we're just going to jump ahead and get used to the notation that we're going to stick with moving forward. All right. Let's try one or two of these, and then that'll be our stopping point. I want the derivative of this. Okay, we still don't really have a great understanding of what a derivative is. Derivative has lots of different applications. At this point, you should be able to tell me one piece. The derivative is the same thing as the slope of the tangent line. Okay, that's what we know so far. A derivative is the slope of a tangent line. All right, so we are going to use this notation, limit as h approaches 0, f of x plus h minus f of x all over h. So, f of x plus h, what does that mean? If I said f of 4, what does that mean?
Plug in 4.
Plug in 4. So when I say f of x plus h, what does that mean? We replace these x's with x plus h. All of them. Minus f of x, that's just what we started with. So now we start doing algebra. X plus h squared, what do we do?
X squared plus 2xh plus h squared.
Minus 8x minus 8h plus 9. If I distribute a negative through this one, so all we've done right now is multiply and distribute. How does this help me? X squared cancels out.
8x.
And 9 cancels. What do you notice about everything that's left? So if I go ahead and reduce an h out of everything, then you can plug in your 0 for h, and we get 2x minus 8. And that is my limit, or the slope of a tangent line at a particular point. And then if I said, well, what's the slope when x is 3? You need to plug it in and say, oh, it's going to be negative 2. If I want the slope when x is 10, 20 minus h is 12. And you can give me the slope at any particular point on that graph. So the derivative is kind of a generic formula that we can use to find the slope at any particular point. So let's go ahead, we're going to do example 5 and then I'm stopping. So I could take this and get the equation of the tangent line. Notice this is the equation that I just found, right? So I know that my derivative, or the equation for the slope of my tangent line, is 2a minus 8, or 2x minus 8, sorry. And that's just from example 4. That was our answer there. So for this particular point, to get my actual slope, you would plug in your 3. slope is -2, then you can plug into y equals mx plus b. Get that my y-intercept is 0. So at that particular point, the equation of the tangent line is y equals -2x. So, I am stopping here today. Are there any questions so far? We likely still have a couple days left in this section. You have a few minutes right now, so you could start the homework, but it is not going to be due for a while. So, this is the assignment. You can start it, but like I said, we probably will spend today and tomorrow, or Tuesday and Wednesday on this section as well. So due on Thursday.